Hello everyone, my name is Colton, and in this talk I'm going to be giving a brief overview of Linux accessibility and the AT-SPI protocol, which is used to query accessibility information. So before we start, it's useful to get a baseline understanding of what the accessibility landscape looks like on Linux. AT-SPI, which is the primary accessibility API for the Linux desktop, is used by applications that need to script a user interface or extract semantic information about the state of the desktop. So some real-world projects using these APIs include the Orca screen reader, Talon Voice, and different GUI testing toolkits. Orca is especially important to the history of the Linux accessibility ecosystem, and there's a lot of great discussion on its mailing list, and also great examples in its codebase if you want to learn more about using AT-SPI. So while accessibility on Linux does have challenges, and we'll get to those later in this video, it has a small but passionate community, and there's a lot of infrastructural work going on behind the scenes. So with that context in mind, we can now talk a bit about the accessibility stack on Linux and how each layer interacts. So as I mentioned, when we use AT-SPI, we can query information about the state of the desktop. So a helpful first step to understanding the accessibility stack is understanding the importance of a GUI toolkit. It's the responsibility of this toolkit to implement the accessibility toolkit, also known as ATK. ATK maps GUI elements to accessibility objects that can be queried via AT-SPI. AT-SPI stands for the Assistive Technology Service Provider Interface, and whenever an application like a screen reader makes an AT-SPI query to the AT-SPI registry that holds all the accessibility info, it is the ATK AT-SPI bridge that's used to link the two. So in summary, we have the application layer related to the GUI toolkit. We have the platform layer related to the registry that goes to the bridge in order to extract info from the application layer. And then finally, we have the assistive technology layer that's going to be actually querying the registry. So a few key points to note on all this. The accessibility stack on Linux can be thought of as having a front end, namely AT-SPI, and a back end, ATK. So even though this might seem like a lot of info and might be a bit overwhelming, if you're not developing your own GUI toolkit, chances are you won't really have to think too much about ATK or the ATK AT-SPI bridge. You just need to make the proper front-end queries with AT-SPI. Second, given the fact that each toolkit needs to implement ATK, it's extremely important for GUI developers to choose toolkits that are accessible and implement ATK. So otherwise, applications that aren't accessible are essentially going to be unusable for screen reader users. Finally, it's important to note that even if toolkits like GTK, Qt, or Electron can be used to create accessible applications, it's ultimately up to the GUI programmer to ensure the final application is accessible by using proper semantic UI design and following best practices for the toolkit generally. So with all that info in mind, we can now talk about how AT-SPI is representing information in the queries. So if you're familiar with web accessibility and how HTML represents a tree of accessible elements, many of the concepts have analogs within AT-SPI. AT-SPI represents a tree of accessible elements where each object contains roles to semantically identify the purpose of the object, information about the UI state, actions that can be run on the object, and references to children elements. So even if an element is off-screen, or it's not the currently focused application, it can often still be queried to extract info. So looking at some sample AT-SPI roles, we have things like label, menu bar, pop-up menu, separator, application, and many more. And some states could include invalid, active, armed, busy, checked, and once again, many others. A user using assistive technology can query AT-SPI to gain info regarding the role and state of a given object and understand its semantic purpose without actually needing to visually look at the screen. In addition to roles and state, a user can do things like query the action interface, which allows a user to focus or click an element without needing to actually use the mouse. So when you go to actually start to create your own client application, the boundary between the protocol, the implementations thereof, and then the bindings on top of these implementations can often be a little bit confusing. So first, at the protocol level, the version of AT-SPI that is currently used is AT-SPI 2. You might see it referred to simply as AT-SPI, but AT-SPI 2 is the version that communicates using the D-bus and is essentially the only one you need to keep in mind. Next, with regards to implementations, there are two main options. There's lib-AT-SPI, which is written in C, and then there's the AT-SPI Rust crate for the Odilia screen reader. So lib-AT-SPI currently has much more usage, and any programming language bindings you see are most likely going to be for that. There are going to be lib-AT-SPI bindings for Vala, GJS, as well as Python. And with Python specifically, there are two options. One named PyATSPI, which only exists for historical reasons, you probably shouldn't use anymore. And then there's the preferred option, those from the PyGObject library, which can be imported using gi.repository.atspi in a workflow similar to how you would import the libraries for Python GTK development. And the Orca screen reader currently uses these PyGObject bindings, which makes it a bit easier if you need to go and look for examples. To get a better understanding of the lib-AT-SPI API and how to use it in real-world scenarios, I recommend taking a look at the docs.gtk.org/ATSPI2 website. And it's not going to provide any specific tutorials or compositional examples, but it generally does do a good job at enumerating all the different classes and methods and all the different ways you can use AT-SPI to extract info. For more robust examples that are compositional, you can take a look at the AT-SPI2 examples repository on GitHub. There are examples here in Python, C, GJS, as well as GJS with TypeScript, the last of which I contributed myself to this repository. You can also take a look at the docs for the Odilia AT-SPI crate if you want an AT-SPI API that's a bit more idiomatic for the Rust programming language specifically. And finally, I'll say that if you want personalized help with AT-SPI, Talon, or anything else whatsoever accessibility related, I offer consulting services myself and would love to help you out. I have a lot of years of experience as both a programmer and user of assistive technology. You can check out my GitHub. I have a lot of different programs, some of which use AT-SPI specifically, and I'm really passionate about helping others in the space. So yeah, if you're interested, please do check my website and get in contact with me if I can be of any help to you. So now that we've surveyed the landscape of Linux accessibility, it's important to talk about the challenges you might run into when developing assistive technology applications. As we mentioned previously, the entire accessibility stack depends on the underlying applications to be programmed in an accessible way. So if that is not done, then the amount of information that AT-SPI can extract is significantly limited. Additionally, sometimes an application may be partially accessible or only apply a certain subset of roles and states. This can make it challenging or tedious to debug assistive technology applications, since it's not always clear if the error originated in the application itself, the lib-AT-SPI binding, or the client program itself. Now, going forward, one facet of Linux accessibility that is rapidly changing is the role of Wayland. Currently, many assistive technology programs are limited to Xorg, the most significant of which being Talon Voice. This is due to the fact that each Wayland compositor is going to export slightly different accessibility info, and some features are altogether missing from certain compositors. So this makes it a high development burden to develop for. In addition to Wayland, there's some new packaging formats like Flatpak, which performs security sandboxing and also create new challenges. So given the fact that Flatpak decouples the accessibility tree in the windowing system, an application like Orca can't really easily verify that an event is coming from the application that has focus. So there's a lot of new work being done on this, a lot of discussion, and specifically a new protocol in development called Newton that addresses some of these challenges. However, for the time being, AT-SPI is still the standard and will probably remain as such for a good amount of time in the future. If you want to go into more detail on this and want to know what is currently lacking in the ecosystem around Wayland accessibility, I recommend taking a look at the Wayland Accessibility Notes GitHub page, and that'll give you a better sense of some of the specific features and how they are implemented in each specific compositor. And now, before we wrap up, I'd like to talk briefly about what the Linux accessibility community needs in order to develop further. Ultimately, the number one unmet need is for more funding and more compliance incentives. Currently, accessibility work is done by a very small group of developers and is significantly underfunded. Companies are generally willing to fund Linux work related to enterprise work or server space, but generally the desktop is left out of these sorts of initiatives. As a positive note, there has been some significant funding from the German Sovereign Tech Fund, and if more governmental entities began to adopt Linux for desktop use, it would make a real big difference due to the accessibility compliance requirements within government institutions. But even beyond monetary resources, accessibility communities could really benefit from more people working on documentation and tooling to improve the developer experience. And finally, even if you aren't a developer, it makes a huge difference when you file accessibility issues with applications on Linux and make a note to bring up accessibility within the software communities you're a part of. Accessibility, frankly, can be easy for some others to forget about, and without it, people with disabilities might be left out of the conversations altogether. So no matter your ability, no matter your level of familiarity, just bringing it up in conversation does really make a big difference in general. So all in all, that's been my opinion on the state of Linux desktop accessibility. I'm really passionate about this space, and I think it's really important for people with disabilities to be able to have the choice to use software that is not controlled by a corporation and is rather community-centric. So yeah, I really do thank you for listening to my presentation, and if you have any questions, please feel free to reach out.